Okay, so we shall begin. Good morning, everyone. We are happy to welcome you to today's webinar on sustainable aviation fuels, organized by the MEDGEM Network, International PtX Hub, and SmartEnergy. So in today's webinar, we will be presenting and discussing the EU's ambitious targets when it comes to SAF, sustainable aviation fuels, and if these targets could present themselves as a business opportunity for the MENA. I will quickly go over our agenda for today. We will commence with opening remarks by the MEDGEM Network Director, Frank Wouters. Then we move on to an introductory session with MEDGEM's key expert in green technologies, Dr. Mustapha Taoumi, who will introduce us to what SAF is and why it matters for the MENA. After this brief introduction and background about SAF, we can begin with our first deep dive with our speaker, Frank Mischler, who is the director of the International Power-to-X Hub. And he will be presenting to us the EU's SAF targets, as well as challenges and opportunities for third countries in that regard. Then our second dive is with Mr. Christian Fauduc, who is the Chief Technology Officer at SmartEnergy. He will present to us SAF business opportunities and immediate actions for the MENA. Our last session for this webinar will be a panel discussion with an open debate after that, where our panelists will be our speakers, Frank Mischler and Christian, and this session will be moderated by Frank Wouters, where we will be discussing how the MENA can position itself in this emerging SAF market. And then we end with closing remarks and some takeaways from Frank as well. So without any further ado, I will pass the floor on to Frank. Please, Frank, go ahead.
Yes, thank you, Tufik, for this great introduction, and it's a pleasure to be here with you today. Thank you also, all of you, for joining. Now, as the director of the MEDGEM Network, it is probably my role also to take a step back before we go into a deep dive. And I just came back from a meeting in Kuwait yesterday. I was invited, although the MEDGEM Network focuses on the Mediterranean, there were also people from the European Union, as well as, of course, in the Gulf. And part of the narrative is, and this is a new geopolitical orientation on behalf of the European Commission, is to look at the southern neighborhood in a new kind of way. And that includes not just North Africa, so the Mediterranean neighborhood, but it now also includes the Gulf. And then, the question is, how can we integrate markets and make it one big clean energy unit where a lot of synergies can take place in terms of transfer of knowledge, transfer of capital, transfer of technology, but also of course flows of energy. And part of the reason why we're here today talking is because we have different price points. It is a lot more cost effective to make some renewable energy or renewable energy fuels based in desert areas where land is cheaper and the resources are better than, for example, in Europe. So that's a natural relationship that is worth exploring, and that's what we're doing today. But it's also important to keep in mind, why are we all doing this? Why are we working on decarbonization and climate action? And I had an interesting discussion yesterday with Adrian Bilal. He's professor at Stanford, and he did groundbreaking research on the social cost of carbon. He issued a working paper last year. It's currently being peer-reviewed, and his conclusion is that the climate modeling that is usually taken, doesn't really take, the overall temperature effects into account and the negative effects that it has on the economy and on human health and premature deaths and all of that associated with increasing temperatures because of climate change. And his conclusion through this new modeling is that the social cost of carbon, actually what it costs to emit CO2, is more than $1,300 per ton, which is 6 times higher than commonly assumed, because the Obama administration in the US already worked on social cost of carbon modeling. And it's 16 times more than the price of a carbon credit in the European emissions trading scheme. So, and these are real costs. These are costs that affect economies, that affect our health, our well-being, and et cetera, et cetera. Last year, mankind emitted 40 gigatons of CO2. So the associated costs with that are more than $50 trillion. And this is something that we accept in one way or the other because we are struggling to reduce emissions. So that is, I think, important to know. He's currently, going through a process of peer reviewing his paper, and I'm really looking forward to seeing the final result. A second, piece of science, if you will, is a paper that we've been writing myself with two professors from Delft University and some others about storage in the energy system. That's also going through peer reviewing right now. So we will have a scientific paper on that. And there we basically looked at, what is storage and what is storage now and what is it in the future. And when you talk to people about storage, and especially in the framework of renewables, then they think, batteries and maybe pumped hydro, etc. But the reality is that 17% of all the energy that we use in a year, so all the primary energy that we consume in a year, 17% is in storage. And that's all molecules. It's oil, coal, and natural gas. If you look at the electrical storage, storage in pumped hydro and in batteries, the molecules are 3,000 times more. So that is, it's such a big difference that, you have to come to the conclusion that if you want to do storage, and storage is a systemically important aspect of our energy system, 17% we store for many reasons, then, you have to think molecules. And, we then modeled the future energy system, which is hopefully sooner rather than later going to be without emissions. There you also need molecules. So molecules are indispensable. Despite the growth and the importance of batteries, you cannot battery your way out of molecular storage because the model that we use shows that even though batteries will grow and there'll be a larger part, it's still going to be much, much less than 1% of all the storage that we need. So then the bottom line is we need molecules now and in the future. We will do a lot more with electricity and direct electrification as much as we can, but we still need a whole bunch of molecules. If we don't clean those up, we will still have emissions. That's the bottom line. So there's a lot of confusion in the recent past because of, the price of hydrogen is not coming down fast enough. So projects are not reaching maturity, et cetera, et cetera. And do we need to do this? The simple answer is really yes. If we don't do hydrogen, if we don't do hydrogen derivatives and sustainable aviation fuel, we will be stuck with pollution. So that's the bottom line. And I think that is the reason why we're here. We're also, in a region. I live in Abu Dhabi, where big airlines are a large part of the economy, and you have the potential to produce sustainable aviation fuels here, but also North Africa, and then you're basically exporting energy in the form of the fuel that you're using. So that's a great pitch. That's the reason why we're here today, and I'm looking forward to an insightful discussion. Thank you, Tawfiq.
Thank you, Frank, for this. We will move on to our first session, which is the introductory session with Dr. Mustapha Taoumi, again, about what is SAF in brief and why it matters for the MENA. Mustapha, the floor is yours.
So, yes, it's a pleasure to be with you today to talk about sustainable aviation fuels. And we'll go over, the whole, details about the SAF, starting by its relationship with climate goals, the production pathways, and also the SAF momentum at a global level, but also some initiative at MENA region, the opportunities that the region has for SAF, and I will close with some recommendations. So the sustainable aviation fuel. Let me begin by placing SAF in the broader climate content. Today, aviation accounts for around 2 to 3% of global CO2 emissions. That may sound small, but it's one of the fastest growing sources of emissions. Without immediate action, as Frank mentioned, emissions from aviation could triple by 2050. Yet in 2022, the SAF represents less than 0.2% of global jet fuel use. To say on a net zero trajectory, we need to scale up this number to over
Mustapha, sorry to introduce. Can you please put it in presentation mode, full screen mode, because we see only the first one plus the ones on the left.
Yes, regarding the net zero trajectory, as I mentioned, we need to scale up from 0.3 million tons today to over 400 million tons, and that will, require a massive investment. Over 1.4 trillion globally, and the MENA region, as we will see later on, is well positioned to become a major contributor. So next, please. Yes, so what exactly is sustainable aviation fuel or SAF? SAF is a cleaner alternative to conventional jet fuel. It is produced from sustainable feedstocks, such as using cooking oil, municipal waste, solid waste, or renewable electricity, or captured CO2. What makes SAF so valuable is that it can reduce life cycle green gas emissions by up to 80%. And importantly, SAF is a drop in fuel to work with existing aircraft engines and airport infrastructure. Its adoption is essential in the aviation sector is to meet its climate target while accommodating, the rising global air traffic. Next, please. So regarding the production pathways, as we can see here, we have two main categories of SAF production pathways. The first one is the bio-based pathway that rely on organic matter like waste, oils, agricultural residues, municipal solid waste. These are more mature and already in use technologies. And we have the second one is the power to liquid, or the eSAF, which use renewable electricity to generate green hydrogen combined with captured CO2. This produce synthetic fuel and offer excellent long-term scalability. So that is, I think, it's an emerging technology, a strategic long-term solution offering also flexibility and a very low carbon intensity. Next, please. So that is, I think I wanted to highlight here the bio-based SAF production pathways. We have 6 methods that have been, already certified. They vary by feedstock and the process, but all must meet stringent and very rigid aviation safety and performance standards. So like the HEFA are already commercial, but others such as the SPA or the PT port to liquid are still scaling up. So understanding, I think this pathway is critical for planning, the investment, but also in the infrastructure, especially in the MENA region where feedstock potential is very high. Here we emphasize the diversity of feedstock, but also we have the blending, limit that we will see also later on. So at this, the certification is now in a good shape, as also the EU has also this what they call the refuel EU aviation regulation, which it is aligned with the key international standards. Next, please. Yeah, next. Yeah. So yes, as I mentioned, those 6 pathways are already approved by the International American Society for Testing and Material, which is accepted with by the EU. And we have also the feedstock diversity because, as I mentioned, this diversification allows for regional customization depending on the resource availability. So it's not really a matter because each country has its own resources and they can clearly and with flexibility to manage those resources to produce SAF. The blending limits are crucial, as we saw in the previous slide. So it depends on the process, or depend also on the feedstock. It varies between 10 and 50%, and we see why those limits are a little bit limiting the usage of SAF. Next, please. So that is, I think, very important just to highlight this port to liquid or ESAF production stages, as we have the electrolysis phase to produce green hydrogen. We have also the CO2 capture phase. Those 2 phases can be combined. We can have the first one, the CO2, the green hydrogen at the later stage, but it can be combined, and we can have all those 2 resources combined to synthesize the hydrocarbon through this Fischer-Tropsch process or the methanol synthesis process. Then we have to go to the refining phase that transform this synthetic crude into the SAF that is aligned with the international standards, the D7566. So that is, I think, very important because MENA region can be, a good platform, platform for the ESAF, production, as it is blessed. The region is blessed with high potential on the renewable energy. For the challenges, I wanted just to highlight that the high cost of the SAF and also the inadequate infrastructure. Those 2 elements, I think, very important. That now the research and development institution are hardly working to overcome them. So next, please. Yeah, just to give you an overview about the cost comparison between the sustainable aviation fuel and the conventional jet fuel. For example, we have the price or the cost is for the SAF is 2 to 7 times the conventional jet fuel. And we have also some environmental benefits that over the conventional jet fuel that can be managed to be embedded in the climate change goals. But also the conventional jet fuel, I think the price volatility is very high risk globally, but it can be, for SAF, the price volatility is very moderate, so that can be an advantage for SAF to be introduced, in the aviation sector. Next, please. Yes, as I said, for the versatile feedstock, it can be an advantage for MENA region for green hydrogen because of the high resource availability of higher resource of renewable energy resources, and the cleaner combustion also include minimal aromatics necessary for seal and compatibility, ensuring a cleaner burn. The SAF certification among the candidates, the top candidate for 100 SAF certification bridging technology to enabled options. That is, I think, just for this SPK aromatic, pathway. That is, I think, I wanted to highlight these resources because of the availability of renewable energy in the MENA region. Yeah, next, please. So why blending, as I mentioned, why blending is required? Because most of the SAF produced today are what we call paraffinic, which means that lack the aromatic compounds found in fossil jet fuels. So aromatic are crucial for certain aircraft, particularly for seal swelling, to provide also fuel leaks. This is why current SAF must be blended up to 50%. But as I mentioned, for the FT SPK is a major step forward because it includes the required aromatics and reducing the blending needs and then bringing us closer to 100% SAF compatibility. Ongoing effort, yes, as I mentioned, the significant, research have been, made and going. Some demonstration flight by Airbus, Boeing, and various airlines have successfully used 100% SAF in test conditions, but full commercial certification is still in progress. So industry, regulation, research institutions are working closely to prove the performance, safety, and material compatibility of and for the blended safe SAF for routine commercial use. So the application for MENA region. Yes, abundant solar and wind resources. That is an advantage because we can have the lowest LCOE in the world, making it ideal for power to liquid or SAF production. And also the organic waste and the biomass are largely, available. Third advantage is the energy infrastructure because, as we know, MENA has a long experience in the and also export of fossil fuels that make naturally suited for scaling SAF. Next, please. Yeah, just to highlight some global SAF momentum, like the Refuel EU Aviation. The EU have set, some targets to reach, for example, 70% by 2030, 2050. But also we have the Clean Skies for Tomorrow, under the World Economic Forum platform. So to enable the transition to net zero flying by 2050. But also we have the CORSIA initiative. This is a carbon offsetting and reduction scheme for international aviation. So it's an emerging global framework under the International Civil Aviation Organization. Next, please. Yeah, at a local level, I think it's very important also to highlight that in all those initiatives, the strong governance support, it's key through clear policies and financial incentives. It's essential to create, a favorable investment environment, but also the strategic partnership between airlines, companies, energy companies, technology providers, but also government are crucial for scaling production and ensuring sustainability. Collaboration among EU and EU stakeholders are also it can be a plus and to build a resilient and low carbon aviation value chain. We witnessed that also countries like Egypt, Saudi Arabia, United Arab Emirates, and Qatar, they are also launching some initiative and some pilots in the SAF sector. Yeah. As I mentioned, the MENA region has plenty of advantages, feedstock abundance, proximity to Europe, which reduce export logistics cost and align with the EU SAF demand, but also the energy sector experience, and with skilled labor, it can be easy to shift to SAF technologies. The last one, please. Thank you. So to seize this opportunity, MENA countries must also act decisively and in coordination. First of all, developing a national SAF roadmap for defining clear targets and strategic pathways, but also to build an investment pipeline through public-private partnership and international financial tools. We have also to establish research and development and innovation partnership, including with European and global actors, strengthening policy readiness. That is, I think, very important to align, with the EU and also the international standards to, have a more clear picture about the trade, possibilities. And also we have the human capital, as I mentioned previously, to build local expertise in SAF technology and feedstock management. This is not just about fuel, but positioning MENA region in the global clean aviation economy. We need, a clarity. We need, a robust strategy and a holistic framework. Thank you very much.
So thank you, Mustapha, for this amazing crash course on SAF and eSAF. I think now we're all ready to dive for a deep dive on the EU SAF targets and the challenges and opportunities for third countries, which will be presented by Frank Mischler, the Director of International PtX Hub. Frank, the floor is yours. I will ask you to take control of the presentation so that you move from slide to slide.
Yes, I did that already. Hello, everybody. Frank Mischler. Very great to talk to all of you. I'm the director of the International PtX Hub. We operate worldwide in many countries, not only on aviation and SAF, but on all PtX topics. And in the region, our main country is Morocco, where we have a big team, but also in Algeria, but punctual kind of with trainings or discussions on specific projects, also in other countries. Oh, I don't. Okay. Well, let me first introduce the case of the EU, and then we can together later on deduce to what extent this is a business case for the MENA region. So first piece of input is if you look back in the last 17, 18 years, the EU imports around 10 metric tons per year, like 20 to 25% of its consumption. The blue bars is the domestic consumption. The green bars is the domestic production. You see there's a shortfall year by year. We have reached now again the same levels as after the COVID pandemic dip. So there is a clear a market for kerosene. Finally, we are there. Okay, sorry for that. So, okay, now quicker. The departing flights, as you see, the darker part, and the problem is on the long range. The short, we may be able to solve with battery electric. It's at its very beginnings, but could be a solution. But that will not tackle really our main problem with the high CO2 emissions. And worse than that, the order books of Airbus and Boeing are full. It will grow to 42,000. That's 60% more than we have today, and you know those planes will be in the air for another 20 to 25, maybe 30 years. So we absolutely need a solution for our planes. This Mustapha already said, there is no other solution in the next 30 years, I would say, for the long-haul flight than SAF. So sustainable aviation fuel. There is, you may have heard, some hydrogen planes. Airbus has worked on it, and Zero Avia, but they are a long way from market maturity. Airbus even postponed it now further, so I don't expect it to come before 2040, and even then not in the mass that we need. So SAF is all we have for the next years. So where is the SAF production right now in the EU? So in 2025, the refuel aviation has started. I will talk about that in a second. And you saw it very briefly in Mustapha's slide, that there is now a very modest goal of SAF, and everyone in the industry clearly says, well, that is not a problem to reach it. Including some say, well, for 2030, we already reached it, or we have enough production in the pipeline for SAF. There is, however, a sub-quota on synthetic aviation fuel. That's the eSAF, or the power to liquid, which is more of an issue. In 2030, 1.2% of total kerosene use has to be synthetic aviation fuels. So now you see those bars, and they seem, well, they are so much higher than what we have to reach. But this is all projects in planning. So there are many projects in Europe in the planning stage, but only one has reached now maturity and starts production. That's Ineratec. So that's not reflected on this slide from EASA yet, because that only happened this week. So Ineratec has the first eSAF plant operating, but that's still not enough. When we usually say it takes between 4 to 5 years to get between a plan and an operating plant, that means if we don't reach final investment decision of those eSAF plants this year or early next year, it will be very difficult to reach it. And fast forward to 2035, now then with these amounts, 9.2 metric tons and 2.3 metric tons of eSAF, respectively, this will be very difficult to reach without imports. And this provides, of course, an opportunity for the MENA region, especially, I would say, on eSAF. On the prices, well, Mustapha had this kind of rough estimates. EASA gives a more accurate picture. These are the reference prices that they published in February this year to facilitate the penalties. So first on the prices, the baseline is the conventional aviation fuel. It sits at 734 euros. That's used, so that this is fluctuating, of course, but that is now used for the penalties that I will explain in a second. The only market price for SAF that we actually have is the SAF produced from used cooking oil, so HEFA, which is at 2,000 euros per ton, so almost 3 times the price. For synthetic aviation fuel, the price is estimated to be much, much higher, like 10 times, 11 times the range of conventional aviation fuel. But here we have to be a little bit more careful because we don't have a market yet. So prices may go down quite significantly once the market is up and running and there are more producers and there's much learning and the price will drop. You may have heard that the EU works a lot with carrots and sticks. So the refuel aviation is a clear stick. It has this clear targets for the coming 25 years. With every 5 years, there's a jump where the SAF target and the eSAF subquota target increases, and to ensure that everyone the fuel producers are obliged to provide this blended fuel to the airports in Europe. If not, they have to pay a penalty, which you see in this little box on the right-hand side. It is the difference between the price of SAF according to this reference prices minus the cost of the conventional aviation fuel times 2, which implies that we have penalties between 2,800 to almost 14,000 euros per ton, which is a lot. It's huge, and that should give incentive enough that the fuel providers provide this blended fuel in the future. But of course, they also depend on production worldwide, which has to be stimulated. Maybe I can say a little bit about that as well. So there are a number of key challenges, and the first is the first mover disadvantage. So I was saying there will be the prices will drop for sure, because right now we have those SAF and eSAF plants. The SAF plants are a mature technology, but the eSAF plants are at demonstration pilot stages. The first industrial plants now come online, but there's a lot of room for learning and different technologies, different approaches. So we can expect prices to drop a lot, which implies that the first company that gets onto the market has a disadvantage, because who would like to have a 10 to 15 year offtake agreement with this company if we know that the prices will be much different in the years to come. The EU acknowledges this, and they vouch that in the forthcoming Sustainable Transport Investment Plan, this will be addressed. How exactly, we don't know, but I learned yesterday that in May, June, this investment plan will be open for consultation, and I invite everyone to look at it once it's open, because it also will have one pillar on international cooperation. And I think that's quite interesting then from a MENA perspective to see, okay, what would it take for us to produce for the European market? Is this incentive enough, or is there something that we would need to get it going? So that's a very important piece for your calculus, I'd say. Another key challenge is the strict EU regulations, especially on the carbon source. There is a list in the renewable energy in the RED about carbon sources that are eligible. But there are many other carbon sources that people would like to use that are CORSIA compliant, but they're not EU compliant. So the EU is quite restrictive in this, which makes it more difficult. So, for instance, there are many companies using municipal solid waste, and that's kind of difficult to get the EU to have it EU compliant. Then there is a competition for the carbon sources as well. So right now, Europe is maybe the strongest market thanks to the targets, but other regions they now start with targets as well. There's a lot of discussion in many world regions. Also, the CORSIA obligations will start in 2027. Currently, almost 100% of the SAF that is used cooking oil. And a lot of this used cooking oil is imported from Australia and Asia, Thailand, Indonesia, China. But there's a big discussion in all of those regions to also invest more in domestic SAF production and use SAF in their own airports, which implies that this used cooking oil is no longer available to Europe or will increase in price. So there might be an input scarcity and a demand to be much more, go to different routes and not rely too much on the HEFA route. And book and claim is not allowed. Book and claim means that you distinguish between the product, kerosene, and the environmental component, the emission saving. So for climate action, it isn't necessary that the one who flies the plane on SAF. So it doesn't matter where the SAF is used. So if there was a producer, say in Australia, and a KLM in Europe buys the environmental claim, they can still use it for their reporting, but the kerosene doesn't have to be shipped from Australia, in this example, to Europe, which comes as a cost and is highly inefficient. So that would be that's existing on the voluntary market, but unfortunately not as part of the EU regulation. The feedstock is our main bottleneck. So I talked a lot about the used cooking oil, the HEFA technology. This is a view on Europe. So you see this very small circle on the left, 0.9, the current supply of SAF made from HEFA. The potential supply roughly double. But if you wanted to have the entire kerosene demand of Europe done by HEFA, you would have 100 times greater demand, which is impossible, right? So that's not a way to go. And on the other side, if you look at the power to liquid, so you produce a jet fuel with renewable energy and then possibly with carbon captured from the air, you would need the entire renewable energy supply of Europe in addition, just as a feedstock for your SAF. That is not impossible, but it's a lot to ask, and the increase in renewable energy has to increase a lot. But that's under the example of that's being done in Europe. And as Frank Wouters said at the beginning, of course, the MENA region has much better potential to produce renewable energy. It's the carbon source that we have to worry about for the production of SAF. Now, looking at how much carbon do we actually have to start to get going? there's a very interesting a report that's coming out that we did with Atmosphere and Solar Belt. They looked at the biomass worldwide, and which is 7,100 million tons, and they then checked, okay, how much of that is in the three world regions that we are mostly interested in: Latin America, Africa, including North Africa, and Asia. So it's roughly half, 3,420,000. And then they were very, very conservative and rigorous, and decreased it even further using environmental criteria. And the story that I want to tell you is that even if you do that and you're very, very conservative and you only include agriculture residues and forest residues, and you're very, very clear we are only talking about waste and not about energy crops. We don't include used cooking oil and many other inputs that you could use. Even with this very, very conservative and limiting way of doing it, you would have enough feedstock in those three continents to produce 20% of the jet fuel in the world using a biomass to liquid route. And a biomass to liquid route means you use the bioenergy for its energy content, but also for its carbon content. If you would include a renewable energy to it and use that as your energy content and the biomass as its carbon content, then in my kind of acronym way, you have a mix between a power to liquid and a biomass to liquid. So it's a PBTL. With this, you reach already 3 times more, 60%. And if you are less strict on your environmental and social sustainability criteria, you could reach even more than 100. But this is, I'm not so kind of married to the actual numbers here. What I want to say is there is enough biomass around, and so that we can get SAF much, much, much higher, much, much more quicker than currently we have with this roughly 1% worldwide. Right. I want to leave you with one example that we are involved in the MENA region. Algeria, I don't know if someone is present here at this meeting today. They decided in their hydrogen strategy to have 5 pilot projects, 2 of which have something to do with aviation fuel. So e-methanol, of course, can be used as a shipping fuel and for the chemical industry as well, and SAF e-fuel. They're working on pilot plants, and we help them designing them, and they are moving very, very fast. So they already have contracted the company that does the design stage. In the presentation that I will share, you will find lots of other information about what we are doing, our publications, and an overview of the kind of services we provide on aviation, and most importantly, our aviation training that we can offer in 1-2 hours, but also a full day, depending how many of those components you would like to have. But this is just for your information. You can then read about it and contact me later on if you're interested. So sorry for the rough start with the slide. Sorry for that. Please get in touch, and if you want to know more about the EU regulations, let me know. I have more to say, I have more slides and all of this. Thank you, and I stop sharing again, and